Okay, think about this for a second. What if you could manage our entire planet's power grid, not by staring at some flat, complicated diagram, but by literally holding it right there in front of you? I know, it sounds like something straight out of science fiction, but this technology is actually becoming a reality today. So let's dive in and see how it all works.
So let's really lean into that idea for a moment. What if you could actually hold and inspect and even manipulate the entire power grid like it was a physical object right here in the room with you? It's a pretty powerful thought, right? And it's the absolute core concept behind what we're about to explore. The thing is, managing a modern energy grid is this absolutely massive high stakes balancing act. We're talking about a sprawling, interconnected web that gets more and more complex every single day, especially as we bring things like wind and solar power online. Just keeping the lights on for everyone, well, it takes constant supervision and some incredibly fast decisions.
And here's the crazy part, for decades, the people in charge have been using tools that, well, they just haven't kept up. They're often stuck looking at static two-dimensional maps and poring over endless spreadsheets of abstract data. This makes it so hard to run what-if scenarios, to respond quickly when a crisis hits, or to get new people trained up effectively. There's this huge disconnect between the data on a screen and the actual physical infrastructure out there in the world. But what if we could finally close that gap? All right, so this is where our story takes a turn. This is where a new kind of technology comes into play, the AI Spatial Human-Machine Interface, or HMI. It's a total breakthrough, designed to give grid operators a completely new way of seeing and controlling our power. So what is this thing exactly? Well, at its heart, it's a mixed reality application. It takes this incredibly detailed, data-packed 3D model of the power grid and just overlays it right onto your view of the real world. This lets operators literally see and interact with the entire grid in physical space. The magic here really comes down to three key ingredients. First, you've got the 3D spatial visualization, which gives operators that realistic, almost bird's-eye view of everything. Then you layer on AI simulations, which lets them test out scenarios and predict what's going to happen. And finally, you have easy interaction, which makes the whole thing feel completely natural to use. Let's break down how these pieces fit together. Okay, so how does the magic actually happen? Let's pop the hood for a minute and see what core technologies make this whole immersive experience even possible. So everything, and I mean everything, starts with this concept called a digital twin. Honestly, the best way to picture it is like a perfect one-to-one real-time flight simulator, but for the entire power grid. It's a virtual model of the physical grid, and it's constantly being updated with live data. This gives operators a complete up-to-the-second picture of exactly what's going on out there. Now, once you have that perfect digital copy, you can start doing some really cool stuff. That's where the AI-powered simulations come in. This is where operators can finally stop just reacting to problems and start being proactive. They can ask those critical what-if questions like, what happens if a massive storm hits this power corridor? Or what's the absolute best way to reroute power during a heat wave? The AI runs all these scenarios and shows them the most likely outcomes. It just closes that gap between theory and reality. And the final piece of the puzzle, how do you actually interact with all this? This is where it gets seriously like something straight out of a movie. Think Tony Stark in his lab in Iron Man. Users can navigate, inspect, and even manipulate parts of this virtual grid using just their hands. They can literally reach out, grab a section of the grid, zoom in, and see exactly what's happening. No mouse, no keyboard, just natural movement. So, we've talked a lot about the how, but now it's time to get to the why. Why does this matter? What does all this incredible tech actually mean for the people on the front lines, the grid operators? How does it make their absolutely critical jobs smarter, faster, and ultimately safer for all of us? And this right here, this shows you just how massive that leap forward is. On one side, you have the old way, static, abstract maps, and a whole lot of guesswork. On the other, you have something that's dynamic and totally immersive. Instead of trying to decode complex spreadsheets, operators get these intuitive 3D visualizations with precise, real-world data. It's a total shift from just interpreting data to truly understanding it. So what does this actually mean on the ground? Well, it breaks down into three game-changing benefits. First, training becomes way more effective. New operators can learn the ropes in a completely immersive but totally risk-free environment. I mean, think about it. You could prevent a huge blackout because an operator has already practiced that exact rare scenario 100 times before it ever happened for real. Second, decision-making just gets faster. In a crisis, that global spatial view lets you respond so much quicker. And third, you get total system awareness. For the first time, operators can truly see how all the different pieces of the grid fit together in physical space. You know, there's a line from the folks who built this that just hits the nail on the head. They say the interface closes the conceptual gap between theoretical data and its application in the real world. And that's really it. It's all about making data intuitive, making it tangible, and making it actionable. All right, so let's zoom out for a second. Where does a technology this futuristic fit in today, and what's coming next? Well, it's pretty clear that this is part of a major shift in computing, a shift towards what people are calling spatial computing. So if you look around at what other big players are doing, you'll see giants like Siemens with their own platforms. But the real difference here is focus. While a lot of those platforms are broad industrial tools that still rely on a traditional screen and a mouse, this system is laser-focused on the energy grid. And it uses a truly immersive, mixed reality interface that you control with your hands. That's the key advantage. So how do they get this amazing tech into the control rooms where it's needed? The plan is actually really smart and modern. It's based on a software as a service model, SaaS, and it's hosted in the cloud. That really lowers the barrier to entry for energy companies. The strategy is all about direct engagement, showing decision makers at demos and conferences exactly what this technology is capable of. And that right there leads us to the final and maybe the biggest question of all. This technology is focused on our energy grids today, but just imagine the possibilities. If you can create a live interactive digital twin of the power grid, what's stopping us from doing the exact same thing for our road and rail networks or any other piece of critical infrastructure? The future of how we manage our world is becoming spatial. And you know what? It's happening right now.